So here's a really complicated word that makes you sound really smart. You go, your mom's like, what are you working on? Mom, I'm working on the intermediate value theorem. It sounds so intelligent, but it's actually, it's not that difficult when you look at it. It's almost like, why do we need a theorem to prove that? So here, let me show you guys. I wrote this nasty looking function because, I don't know, I just want a nasty one. Okay, prove that, don't say that out loud. Hopefully my video didn't hear that. Okay, prove that this guy right here, this f of x, takes on the value of -1 and the interval, so it gives us an interval. Now these are x values right here. So from -2 to 0. So if we had a graph, I suppose it would look like this. It would be like from -2, we'll say this is 1, 2. So that's -1, -2 to 0. Is that, dang it. Hold on, let me fix this. Okay, sorry about that. And then let's see, we'll do this is 0 right there, and this would be 1, this would be right there, that would be 2. So what this is saying, between -2 and 0, that's between this guy and this guy, is there a value that we can plug in for x? We'll call it c. Is there a value c that we can get that will give us, let's see, f of c, is there a value c that will give us -1? Okay, and to do this, we're going to use the concept of the intermediate value theorem. Now, I haven't even explained what that theorem is yet, but I do kind of just want to talk about how you might think about doing this. Okay, and one very important concept that I want you guys to think about is this function continuous? Okay, and more importantly, is it continuous in this interval? So like from -2 to 0, is it continuous? Is there like a jump in there? Is there an undefined hole or asymptote? I don't know. Well, I do know. I just have to look at it. So let's look at this guy right here. See the numerator right here? Is there anything stopping you from plugging anything you want in the numerator? No. No, there's nothing. Then we have a quadratic looking thing right here. Okay, and then down here we have a 4 times the radical x plus 5. Now, we know radicals. There's limits on radicals. You can't plug in anything you want into radicals. And also, you can't plug in anything into a denominator, right? Okay, so we do have something going on here. So let's first look at the radical since he's first. What can I not plug into x? I can't plug in -5. Because if I plug in -5, then I would get -5, I would get 0, right? 0 times 4, that would be 0 on the denominator. So I can't plug in -5. Well, can I plug in -6?
No.
Right, because if I plug in -6 right there, that would be -6 and 5, that would be -1. The square root of -1? Can't do it. So anything less than -5, can I plug in? No, I can't. Can I plug in anything greater than -5? Okay, so let's say the domain for this guy right there is going to be from -5 to infinity. And we do not include -5, right? Because -5 didn't work. Okay, here, so for this interval right here, this is our domain. So it's continuous from -5 to infinity. Is this interval inside there?
Yes.
Yes, it is. Now, this interval is including the -2 and the 0. So it's continuous between -2 and 0, right? You guys agree? That means there's no jump, there's no undefined point. That means it's just straight through those two x values. And so how's that going to help us? How's that going to give us knowledge on how to determine if there's a -1 value on our graph? Now -1 we're going to put right here. I'm just going to do a horizontal line right here. So that's -1. So is there a point between here and here? And we said, is there a point C right here that will give us a -1? Well, how can we know that for sure? Wait, you said plug it in. What am I going to plug in? What we're going to use, we're going to use the idea of the intermediate value theorem. Now, what the intermediate value theorem says is that if you have a continuous function on your interval, which we do, in this interval it's continuous, then what you would want to do is you want to plug in -2 and plug in 0 to see what you get. Let's see, and we'll talk about why in a second. So let's plug in -2. Plug in -2, we go 2, -2 squared minus -2. all over 4 times the square root of negative 2 plus 5. Okay, I'm going to simplify this dude. Let's see, we got, that's going to be 4 times 2 is 8. So 8 plus 2, that's going to be 10, right? But did I forget something?
The minus 2 at the very end.
The minus 2? Yeah, I almost forgot that minus 2. Let's see. Let's move that guy over. That minus 2 is so sneaky. So I have minus 2 right there. Okay, so I have 10 on the numerator. And on the denominator, let's see what I get. I get negative 2 plus 5. I'm going to need a calculator person here in a second. Negative 2 plus 5 is 3, so I have 4 times radical 3. And I'm going to subtract 2 from that. Can someone plug that into your calculator and give me an approximate value? You guys all get negative 0.556? Wait, does 6 get rounded up? So it rounds up because there's a 6 after that. Okay, so I get negative 0.557. So that means that at negative 2, we're going to go down to negative 5, which is right about right there. So I'm going to put a dot right there. It's right over my 2, but you can see it. Okay, now let's plug in the 0. If I plug in 0, ooh, I love plugging in zeros. So 2 times 0 raised to the second power plus, I'm sorry, it's minus 0 all over 4 times 0 plus 5. Okay, so the top, we're going to get 0. So we have 0. The bottom, what's that? Oh, I forgot the minus 2, huh? Oh, I almost forgot the minus 2 again. Okay, so I get 0 up top, and on the bottom, it doesn't even matter what you get, right? Well, it does, because if you get a 0 on the bottom, then it's undefined. But will I get a 0 on the bottom?
No.
No, I'm going to get 4 rad 5. Okay, but, so that's just going to go to 0, right? So we're going to put that to 0. We're going to subtract the 2 from 0, so what do we get? Negative 2. Oh, that's pretty. Okay, so I'm going to go down here to negative 2. Let's see, let's put a negative 2 right here, and we're going to put a dot right there. So from this point to this point, because I know it's continuous, this line's going to be like, or it's going to be like, or this line's going to be like, we don't know what it's going to be like, but we know that it's going to connect, right? And no matter how you do it, you're going to have to cross over this negative 1 line, right? You guys agree?
Yeah.
Okay, so therefore, we just used the intermediate value theorem, guys. Therefore, f of x does take on the value on the value of negative 1 in this interval, negative 2 to 0. And that's all the intermediate value theorem says. That's it. You don't have to do anything else with it.
Did we learn this?
So just to recap, we plugged in negative 2 and 0, and we got this point and this point. Because this point is greater than negative 1, and this point down here is negative, or less than negative 1, I know that I'm going to cross over negative 1. Yeah, because if I go from negative 0.557 to this, to negative 2, I'm going to cross over negative 1, right? Okay. So let's look at the next one. This next one, hold on, I got to fix because I forgot to correct it. So just like before, but this time, it's y equals 0. I mean, to get a root, y has to equal 0, right? So we need to see, as we go from 1, 2 to 6, let's see, 3, 4, 5, 6, does the line cross over the x-axis? Do we have a root? I don't know. Well, if we have a point above the x-axis for 2 and a point below the x-axis for 6, then we know we're going to have a root in there. Okay, if it's the opposite, the 2 gives you a point below and the 6 gives you a point above, then we also have a root there. Now keep in mind too, remember, that we... What are you doing? Don't know what this line's going to do between these 2 points. It could go right here and then connect. I don't know if it would do that, but it can go like this and then connect, in which case we have a couple more roots, or it can go like right here. I mean, I don't know. We don't know what it is unless we actually graph it. So we just want to know if there's a point below and above, or above and below the line. So we're going to have to take this 2 right here and plug them in, and take the 6 and plug them in at 2 separate times to see what values of f of x it gives us. Bam! Okay, so here I plugged it in. I plugged the 2 into the x values, and here I plugged the 6 into our x values. And now I have to simplify. We're going to need a calculator for this because it does get kind of hairy. This is going to be a 4, and multiplying that by 2 would be an 8. So we have an 8 minus 2, which would be 6. And then on the bottom, I'm going to get 4 times radical 7. So we're going to see what we get right there. Now, we actually don't need to solve it all the way. I mean, I'm going to approximate it, but we just need to know right now that that is a positive number. When I do when I plug in the 6, I get 36 right there, times 2 is going to be 72. 72 minus the 6 is going to give us 66. And so I have 66 over 4 times radical 11. And I just realized that I forgot to subtract the 2. Okay, so let me go ahead and move this over here. Gotta subtract the 2. That's right, I remember doing this before. I wasn't able to do this without a calculator. Okay, so now I have this minus 2 and this minus 2. Okay, so I don't know if it's positive or negative. So that's why I definitely will need a calculator here. So I'm going to go ahead and plug those in the calculator and write down the values. Okay, for this top one right here, I get negative 1.433, and this other one I get 2.97 and then 5, but it doesn't really matter. I ran out of space right there. What matters is that this is a negative number f of x, and this is a positive f of x. So that means we're going to have, for the 2, we have a point down here, and we have, for the 6, a point up here. And because this is continuous, and because we know the intermediate value theorem, we know that a root does exist. So we can say, therefore, a root exists in the interval 2, 6. Cool. The next question says, use the intermediate value theorem to narrow down the interval that contains the root found in example 2. So to narrow it down, all that means is to make the interval smaller. Right now the interval that we have is 2 to 6. That interval has a distance of 4. Okay, we can narrow this down by, I don't know, let's try 2 and 4. Or even we can jump even smaller, 2 and 3. Does the root actually exist between 2 and 3? Now that would be between right here and here. So I'm curious, does the root like go right there, or is it somewhere else? I don't know. But and then the only way you can find that out is if you actually plug in the 2 and the 3 to see if you still have a positive, a negative on this side, and for the 3, do I get a positive point? If I don't get a positive, if I get another negative, then I don't have the root between the 2 and the 3. So I have to adjust my interval. This interval is only a distance of 1. So that would be making or narrowing down, making the interval smaller. Sometimes problems say something like, instead of like just narrow down, maybe they say narrow down to an interval of 0.5. And so you'd have to change your intervals so that you wouldn't get a 1 right there, you would get a 0.5. So let me plug the 2, well actually we already did plug the 2, and let me plug the 3 in to see if we get a positive. Okay, I plugged it all into a calculator. I plugged the 3 in right here. I plugged this all into a calculator, I got negative 0.674. So now because I got a negative number with the 3, that means we went too far this way for our interval. And so we still have a point actually that's below the x-axis, and so we know between these 2 points that we probably don't have a root there. So what we're going to want to do is let's use 3 this time. Let's change our interval. We're going to use 3, and this time I'm going to use 3 because that negative number, that f of x, is closer to the 0. And so I'm going to try 3 and 4 right here. So now I just have to plug in the 4 to see if I get a positive number there. If I get a positive number there, that means at 4 the line finally crosses over the x-axis, and so that's where our root is. And then if it's true, then we have narrowed down our interval. All right, so when I plugged it in, I got positive 0.333, and it just keeps going on. So now we have a positive. So now when we plugged in that one, we got a negative. When we plugged in that one, we got a positive. That means we know that the root still exists between this interval. So that's our answer for this question, because we just had to narrow down the interval. Hope that helps.